everyone, I'm Jim White. This video is about Aircrete. Aircrete is basically concrete that is mixed with foam in order to entrain air bubbles into the concrete. This makes Aircrete light enough to float and also makes it a fairly good high temperature thermal insulator. Some say Aircrete is the building material of the future. It has some interesting properties, and that might very well be true. In order to start experimenting with Aircrete, the first thing you need is a bag of Portland cement, which you can get at places like Lowe's, Home Depot, and Menards. Unfortunately, it comes in 94-pound bags, which are usually dirty and dusty and hard to handle. A 94-pound bag is approximately $10. What I did was, when I wheeled the bag of cement out of the store on a flatbed cart, I took it to my car, opened it up, and I had brought 3 5-gallon buckets and a box knife and a garden trowel with me. And I cut the bag open and transferred the cement into the 3 5-gallon buckets. Then I put the empty bag in the store's trash container. Now I had 3 buckets weighing 30-some pounds each. It was nice and clean, and I could put in my vehicle to bring home. So that's one way to do it. Once you have Portland cement at home, the fun can begin. In order to work with small batches of mix, it's necessary to get rid of all the lumps that are normally in the concrete, or I should say cement. This is Portland cement right out of the bag, and you can see all the lumps that are in there. And they're going to affect your mix in small quantities. In a large mixer, these would normally be broken up. Okay, now we're ready to get rid of our lumps in our cement. And I found these in a local store in the kitchen department. These were a set of 3 for around $10. And I like these because the screen is kind of backed up with some reinforcement. So what we're going to do is put our cement through one of these. And of course, most of it will go through, but not the lumps. And I'm going to put the lumps back in the pan. We'll smash them up. We don't want to smash them up in the screen. We might damage it. Okay, let's smash up some lumps. I just have a 2x2 here. Okay, I think that's enough to get the idea. Now we have nice powdered Portland cement that we can use to mix up small test batches of our Aircrete. Okay, the standard ratio that I see a lot for making the cement mixture is a 94-pound bag of cement to 6 gallons of water. Now, of course, we don't want to mix up that much stuff, so that turns out just to be a ratio by weight of 1.88 to 1. So for every pound of water, you need 1.88 pounds of cement. And of course, you can use kilograms or whatever. It's just a ratio. So I have 2 cups here that I plan to use. Plan to use this one for cement and this one for water. Now, if you have a scale like this, you can weigh it out with that. But if you don't, you can make a balance like this. And I just have a small piece of wood glued to the bottom there. And this is a measure to where the cement cup will be, and this distance here is to the water cup. Now for the ratio of 1.88 to 1, I arbitrarily chose 10 inches for the distance out to the water cup. And then based on that distance, we come up with 5.32 inches for the distance to the cement cup. And 0.32 inches is approximately 5/16 in our crazy measurement system here in the U.S. So, of course, these can be centimeters or whatever, as long as the ratio is right. So, the most cups have something in the center of them, a mark in the center. So, what I did was line up that center of the cup with the line that's 10 inches out, and then I glued a piece of wood up against the cup, so I don't have to be measuring that all the time. And the cement cup's the same way. It has a little dimple in the center, so that originally that was lined up with the line and then a piece of wood glued, because of course you can't see the line when the cup's full of cement. So now you can see that this cup and being the water cup being further out, the balance is way off. So I'm going to use a bolt here and this rubber eraser to adjust my tare weights. So I'll get close with the bolt. Well, actually that's pretty good, but I could move this eraser also to balance in finer steps. So let's fill our cup with cement. Now this is why volume measurements are difficult, because you can see where the cement level is there, and few taps and it goes way down because there's a lot of air entrained with the cement powder. Okay, there we have some cement. Let's put it up against the piece of wood. And now we can start pouring in some water. Looks like I didn't have enough, but we're pretty close there. So I'd say that's close enough. But if you put in too much water, it's easy to just remove some with a paper towel. Or if you want to add water slowly to get a really good balance, you can just squeeze a wet paper towel and drop water into it. So luckily these measurements don't have to be accurate to 3 decimal points or anything. So there we have, it turns out the cement cup is 1.5 cups filled to the brim like that. And we have close to a cup of water there. I think it's about 0.8 of a cup. And if you want to work in slightly larger batches and with bigger containers, your balance scale here could be with a 2x4 or anything sturdier. Well, all these calculations have made my head spin, so why don't we take a break and go outside for a few minutes, and then we can continue on. Well, it's a beautiful day here in northern Ohio. Look at that small plane. He's awfully low. Oh, he's flying straight towards me. I'm gonna die. Who can finish my video? Wow, that was close. Notice the power lines running along the roadway there. These crop duster pilots have to really be good. Okay, there's our cement and our water. But we have a third ingredient, which is our foam. So I'm going to make a measuring device for foam. I filled this bottle with 2.5 cups of water, which is roughly the volume of our other ingredients. We're going to work in ratios, so the accuracy is really not that important. But I'm going to mark this bottle at the water level and then cut it off to make a cup for measuring our foam. Okay, next we'll mix up the cement part of our Aircrete. Okay, this part is kind of long and boring, but I wanted you to see in real time how long it really takes. You can skip ahead if you're not interested in that. And we have a nice creamy mixture now. So next we want to add foam to the cement mix. Now I made my foam generator by attaching a piece of silicone rubber hose that I happen to have and use some RTV to as an adhesive to hold it in place. Another possibility is to use a soda straw, and then the old trusty hot glue gun could be used to hold it in place. Okay, let's see how much foam one of these produces. I've affixed a milkshake straw to a full can with hot glue, and in this gallon jug I've drilled a hole for this to fit into. And I'm squirting foam. Just shake it up again to make sure. Looks like the foam's seeping out of the top of the can as well. Well, there's at least a gallon. And I think we're done. So there's a little more than a gallon of foam from one can. Okay, here is our foam 13 hours after we shot it into the container. And there's still some body left to it. So here's the cup that we made that's equal to the volume of our ingredients, which is kind of arbitrary, but at least something we can repeat. Here's the foam generator, shaving cream with a tube attached so we can get to the bottom of our container. Okay, there's one measure of foam. And we'll mix that into our cement. Shake the can up. There's 2 measures of foam. They're up again. So that makes 3 measures of foam. So there's a nice creamy mixture which we'll pour into our mold. Okay, let's shake it down level, and we'll put a lid on it to eliminate evaporation. Concrete doesn't dry, it sets. There's a chemical reaction that takes place. You can actually pour concrete underwater and it will set up. Here are 4 batches of Aircrete in 4 different containers. The top one is the one that you saw me mix up with the 3 measures of foam. The one below that utilized 2 measures of foam. The one below that was 1 measure of foam. And the one on the bottom is only the cement and water. So you can see how the level gets higher in the container as we use more foam. So let's open these containers up and see what we have. Here's the one that is just cement and water. This one used the 1 measure of foam. Still damp to the touch because it's been sealed up. Here's the 2 measures of foam. And the last one here is the 3 measures of foam. Okay, let's see if any of our samples can float. If any of them would, it would be the one with the three measures of foam. And it does float. Just barely. So I doubt that the one with the 2 measures will float. Well, it's very close, but not quite. So obviously, neither of the other 2 are going to float. Okay, let's determine the volume of each of our 4 samples. This sample is the cement and water only. We'll zero the scale and lower it into the water. You don't want to touch in the sides or the bottom. So I'm showing 324 grams. So that means this sample has a volume of 324 milliliters. Okay, this sample here is our the one we made with only 1 volume of foam. So I've zeroed the scale. I'll lower it in. And I'm showing 463 grams, which means it has a volume of 463 milliliters. This sample is our 2 measures of foam, and we'll lower that into the water. And I'm showing 547 grams, which means it has a volume of 547 milliliters. Okay, since we know that sample number 4 floats, we have to do something a little different. So I've arranged a weight to actually push it down into the water. We'll zero our scale. Okay. Now we've got to go a hair further. Okay, it's submerged, and I'm measuring 765 grams, which is a volume of 765 milliliters. Okay, here is kind of a summary of what we've learned with the experiment so far. Off camera, I weighed the samples, and these are the weights for the 4 samples. We determined the volume of the samples through the water displacement. We did that on camera. Off camera, I also measured the thickness of the samples. Now here, we're showing the ratio of the volume compared to sample 1. So for sample 2, it had a volume of 463 milliliters, and sample 1 was 324, so that ratio is 1.43. Same for sample 3, and here's the calculation for sample 4. Now, doing the same thing with the thicknesses, just as kind of a double check, I get very similar ratios. I was actually surprised they were that close. Then I calculated the ratio of volume as we added foam to what we would get with an ideal foam. And we put in a volume of foam equal to the volume of the other ingredients. Ideally, we should get twice the volume. And in our experiments, we only got 72% of that ideal ratio. For sample 3, we should have got 3 times the volume, but we only got 1.69. So that's 0.56. And for sample 4, we should have got 4 times the volume if we had an ideal foam. We only got 2.36. So that ratio is 0.59. So here we lost about 30% of our foam, and with these we lost about 40% of our foam. Now we also need a better way of measuring foam volume. So this ratio might be a good way of comparing different surfactants and the amount of water added to the surfactant. So I hope some folks will start experimenting and give us your results, and maybe we all can learn something. Now, we need some strength testing, and we need to know what happens with other common ingredients of concrete, which are sand and lime. So experiment away and let us know what you learn.